Example 20.6 says, calculate the time it takes for that many atoms of an isotope to disintegrate to the point where 8.9 times 10 to the 17 atoms are left over, and they give you the half-life of the isotope. So they give us the half-life, 73.5 hours. They give you the initial amount, so NO is 6.75 times 10 to the 18, and NT is just going to be 8.9 times 10 to the 17. And they're looking for time. So from the previous slide, we know the equation is natural log of NO divided by N, so they didn't actually put a T right there, is equal to the natural log of 2 divided by the half-life times T. So if I'm looking for T, I'm just going to divide by the natural log of 2 on both sides. Oh, sorry, natural log of 2 divided by the half-life. So my time is just going to be the natural log of 6.75 times 10 to the 18 divided by 8.9 times 10 to the 17 divided by the natural log of 2 divided by the half-life, which is 73.5 hours. So the time it takes is 214.8 hours. When you're dealing with a very big problem like this, just make sure all of your parentheses are consistent in your calculator. You're going to have to make sure this is within parentheses by itself, and then this also needs to be in parentheses before you divide them out. And that if you're finding math errors, it's probably because your parentheses are a little bit messed up. So if you want to do the top first and then the bottom, that might help you make a little bit more sense of everything. Example 20.7 says a particular isotope has a half-life of 17.9 minutes. How many atoms of this isotope remain? So we're looking for N. After a sample containing 4 times 10 to the 19 atoms is left for 21.2 minutes. So NO is 4 times 10 to the 19, and time is 21.2 minutes. Always make sure that if you're dealing with this, these have to be the same. You might have to convert one to the other if you have minutes and seconds or seconds and hours. Just make sure that they are consistent with each other. So now we just need to have this equation, natural log of NO divided by N is equal to the natural log of 2 divided by your half-life times time. So we could do the right-hand side right now. So I get 0.821. Those minutes are going to cancel, and this is not going to have any units. So that's going to be on the right-hand side. On my left-hand side, I have natural log of your initial amount divided by N. And if I need to go any further, I need to get rid of that natural log out front. So I'm going to have to take the e to the power on both sides to get rid of that natural log. So when I rewrite that, I have my starting amount divided by N is equal to the e to the 0.821 power. So our NO is 4 times 10 to the 19. And when I do the e to the power of 0.821, I get 2.27. So now I'm trying to get this isolated. So I'm going to multiply it on both sides. And then I'm going to then divide out the 2.27. So I'm going to rewrite this to where it makes more sense. So when I move everything around, I get N is equal to 4 times 10 to the 19 atoms divided by 2.27. So my amount of atoms after 21.2 minutes is 1.76 times 10 to the 19 atoms. The good news is we don't actually have to always have it in atoms. What happens if they give you in mass, or give you in moles, or they give you in molarity, or even if they give you in atoms? You can use this equation in any form and it should give you the right answer. So they rewrote this equation for the M is mass and the A, that's concentration. So you could just replace it as long as you keep everything consistent. Where the A naught represents your initial amount and the A represents the amount after that specific time. And once again, another way you could write this equation is your A is equal to A naught e to the negative KT. So it's the exact same equation as this. I've just moved things around. Maybe it makes your life a little bit simpler, but this is the exact same equation that's just moved around a little bit. Example 20.8 says calculate the half-life of an isotope if the activity of a sample was reduced to 45% of its original activity in 1.08 years. So they gave us our time is equal to 1.08 years. And they don't give you an actual value for your amount, but they give you in percents. So I can actually use the exact same equation, just change your amounts to percents. So our NO is going to be 100%, and our N is going to be 45%, because you're always starting with 100%. We're looking for our half-life. So that equation is the natural log of NO divided by N is equal to natural log of 2 divided by your half-life times your time. So let's plug in those values. Okay. So I get 0.7985, and then I get the natural log of 2 is just 0.693. So if I want to isolate and get half-life by itself, I'm going to start by dividing by 1.08 years. So I then have 0.739 is equal to 0.693 divided by your half-life. So now I just need to get half-life by itself. So I'm going to rearrange this, and when I do that, I find that half-life is just going to be equal to 0.693 divided by 0.739. So my half-life is going to be 0.937 years.